Hello, and welcome to another lesson from Level Up Mathematics. And today we are going to learn how to solve a system of 3 equations and 3 unknowns by the elimination method. Now, I'll go through the steps first, but just know the steps will seem a little overwhelming until you put this into practice. For right now, I would just write down the steps so that you can refer back to them when you're working these problems on your own later. So, step 1 is you want to make sure all 3 equations are in standard form. AX plus BY plus CZ equals D. All right. The second thing you want to do is you want to pick a variable to eliminate. Now, when you're choosing which variable to eliminate, it could be X, Y, or Z. You just want to pick the easiest one to eliminate. And we'll talk about in a moment how to decide which one is easiest to eliminate. Now you're going to perform 2 eliminations. In the first elimination, you're going to select a pair of equations. It could be 1 and 2, 2 and 3, or 1 and 3 that you're going to combine. That will allow you to create a new equation with only 2 variables. Then in your second elimination, you're going to pick a different pair of equations and eliminate the exact same variable to create a second new equation. Then in step 5, you're going to create a 2 by 2 system. In other words, a system of 2 equations and 2 unknowns. From the equations you formed in steps 3 and 4 and solve that system for both of the remaining variables. Step 6, you'll back substitute by plugging in the 2 known variables into one of the 3 given equations to find the value of the third variable. And you'll write your final solution as an ordered triplet. X, comma, Y, comma, Z. And the order is very important. So you have to make sure the X comes first, then Y, then Z. Excuse me. Now let's try these steps with our first system here. In example 1, it says solve the system of 3 equations below by elimination. Now what I want you to note in this first system is step 1 has already been done for you. All 3 equations are in standard form. So we're ready to go to step 2 through 4. So in step 2, you want to choose a variable to eliminate. So what you can do is you can look at the x's. You have a 2x, a 6x, and a negative 4x. Then look at the y's. You have a 1y, a negative 3y, and a 4y. And then look at the z's. You have a positive z, a negative z, and a negative z. So to me, the easiest variable to eliminate in this problem is going to be the z, because on row 1 we have a positive z and on row 2 we have a negative z. Okay, so we've chosen the variable that we're going to eliminate. So we did step 2. Okay, now in step 3 and 4 you're going to perform 2 eliminations. Let's start with the first elimination. You're going to select a pair of equations to combine that will allow you to create a new equation with only 2 variables. So I'm looking at row 1, 2x plus y plus c, and row 2, 6x minus 3y minus c. The reason I'm looking at those 2 rows is if I were to combine those 2 equations, the z's would eliminate because I have opposites. And the way I'm going to write down which 2 equations I'm going to use is I'm going to write row 1 plus row 2. I'm going to combine row 1 with row 2. So let's see what we do when we combine those. So you're going to, first of all, combine 6x, or 2x with 6x, and that will give you 8x. Then you're going to combine 1y with negative 3y. And that will give you negative 2y. Then you're going to combine positive z with negative z, and that will eliminate. And finally, you're going to combine 15 with 35, and that will give you 50. So this was step 3. In the first elimination, select a pair of equations to combine that would allow you to create a new equation with only 2 variables. All right, in step 4, we're going to do another elimination where we pick a different pair of equations and eliminate the exact same variable. So now I'm going to look at my system again, and because I used row 1 and row 2 in my first elimination, I have to use row 3 in my second elimination. I have to use row 3, okay? And I can combine row 3 with row 2 or row 1. It doesn't matter, all right? So since I want to eliminate the z again, I think it would be easiest because I'm noticing I have a positive z here and a negative z there. I'm thinking the easiest way to use row 3 is to combine row 3 with row 1. All right. Now, when we do that, let me erase these. I'm going to combine row 3 with row 1. So 2x plus negative 4x would give me negative 2x. Then you're going to take 4y and combine it with 1y. And that will give you 5y. Then you're going to combine positive z with negative z. So the z's cancel out. And then you're going to combine 15 plus negative 14. And that will give you positive 1. All right, so that was step 4. Now, step 5 says create a 2 by 2 system from the equations formed in step 3 and 4. So I'm going to take these new equations that I just formed and write them down here. 8x minus 2y equals 50. And negative 2x plus 5y equals 1. And I want to solve this new 2 by 2 system, 2 equations and 2 unknowns. So to do that, I want to eliminate one of the variables. Well, I think I'm going to eliminate x because if I were to multiply this bottom equation by 4, that would give me a negative 8x as my first term, and I have 8x as my first term on the top. So let me rewrite this top equation. Don't do anything to the top. But the bottom equation would become 4 times negative 2x, which would be negative 8x. 4 times 5y would be 20y, and 4 times 1 would give you 4. Now, let's combine these together. The x's will eliminate. Negative 2y plus 20y is 18y. 50 plus 4 is 54. And 54 divided by 18 is 3. So now I know the value of y. Now, to find the value of x, I'm just going to plug that y into this top equation. 8x minus 2 parentheses equals 50. And I want to plug in my value of y, which is 3. So this would be 8x minus 6 equals 50. Add 6 to both sides to get 8x equals 56. And then divide by 8. Okay. So now we know x and we know y. The only thing we don't know is z. So now we're going to do step 6, back substitute, by plugging in the 2 known variables, that's the 7 and the 3, into one of the 3 given equations. So you're going to go back to this original equation here, at the very start of the problem, and you're going to plug those 2 values to any one of the equations you want. I'll just choose the first one. So write down the one that you choose. I'm going to use 2x plus y plus z equals 15. And then for the x, I'll substitute in a 7. For the y, I'll substitute in a 3 plus z equals 15. So 2 times 7 is 14 plus 3 plus z equals 15. So 17 plus z equals 15. Therefore, z equals 15 minus 17, or negative 2. So 7, that's x, y is 3, and z is negative 2. And we write our answer as an ordered triplet. 7, 3, negative 2. All right, example 3. Solve the 3 by 3 system shown below. So in step A, we're going to choose a variable to eliminate and perform 2 eliminations to create a 2 by 2 system. So I'm looking at the x's. We have a 4x, negative 2x, and a 5x. Now I'll look at the y's. I have a 1y, a 4y, and a negative 1y. Ooh, that sounds promising. And then for the z's, I have a negative 3z, a positive 2z, and a negative 7z. So for me, I think the easiest variable to eliminate here would be y. Now my first elimination will be row 1 plus row 3. Now the reason I chose those two rows is because in row 1 I had a 1y, and in row 3 I had a negative 1y. And so I can clearly see if I combine those, I can get the y's to eliminate. All right, so let's combine row 1 with row 3. All right, so row 1, 4x, combined with row 3, 5x, and that gives me 9x. Now take 1y plus negative y, and that eliminates. Then combine negative 3z with negative 7z to get negative 10z. Then combine negative 6 with negative 19 to get negative 25. All right, so now we've done the first elimination. Now we have to do another elimination. But this time, because I used row 1 and row 3, I'm forced to do something with row 2. I'm going to have to do something with row 2. So I'm wanting, remember, to eliminate the y's. Let me write down that we have to use row 2, okay? I'm wanting to eliminate the y's. So let's look at I want to see what I can combine. Let's see. I have a 4y here, and I have a negative y there. So if I were to multiply that second equation by 4, let's do that. If I were to multiply that that third equation by 4, that would give me a negative 4y on the bottom row. So that's what we're going to do. So let me write down what we're going to do down here. We're going to combine row 2 with 4 times row 3. So in other words, I'm going to multiply row 3 by 4. So let's see what I get when I do that. 4 times 5x is 20x. 4 times negative y is negative 4y. 4 times negative 7z would be negative 28z. And 4 times negative 19 times 4, that would be negative 76. Negative 76. Let me move this down here a little bit so I have some room. Negative 76. So I want to combine, I did 4 times row 3, and I want to combine that with row 2. So let me highlight what we're combining. Row 2 is right here. I'm combining negative 2x with 20x, and that would give me positive 18x. Then I'm combining 4y with negative 4y, and that would cancel out. Then I'm combining 2z with negative 28z, so that would give me negative 26z equals, and then I'm combining 38 with negative 76, so that would give me negative 38. I believe, just let me make sure, 76 minus 38. Yes. All right, now I have eliminated the y's from this problem. So I'm going to write down my new system, which is 9x minus 10z equals negative 25. And I want to combine that with 18x minus 26z equals negative 38. Now I'm going to solve this by elimination. So I'm going to multiply this top row by negative 2 so that I can turn that 9x into a negative 18x. All right, and when I do that, that's going to give me negative 18x, positive 20z equals positive 50. 18x minus 26z equals negative 38. So this would zero out, and I'd get negative 6z equals negative 12. Now divide, and that gives me positive 2. All right, I've got z. Now I'm going to find x. So I'm going to take 9x minus 10, and I'll plug in the 2 equals negative 38, and we'll solve for x. So this would be 9x minus 20 equals negative 38. Add 20 to both sides, and we get negative 38 plus 20 would be what? Negative 18. So x equals negative 2. All right, now finally, use substitution to find the value of y. So I'm going to use, from my original problem, I'll just write down the first equation. And I'll plug in my known values. So I know x is negative 2. I do not know y, but I know that z is positive 2. And all of that's going to equal negative 6. So negative 8 plus y minus 6 equals negative 6. Combining like terms, I get y minus 14 equals negative 16. Add 14. Negative 16 plus 14 would be 2. So x was negative 2, y was positive 2, and z was positive 2. All right. For our final problem, we have a system. It's already in standard form. So I want to look at it and see which variables to eliminate. And right off the bat, my eye is drawn to this positive 3z and this negative 3z. So I'm thinking I'm going to eliminate the z's. All right. So to eliminate the z's, I'm going to start out by adding row 1 plus row 2. So if I combine row 1, 4x plus 1x, that would give me 5x. Then combine negative 2y plus 5y to get positive 3y. Combine 3z and negative 3z, those will eliminate. And then combine 23 minus 37, which would give me negative 14. All right, so I did my first elimination. Now, I used row 1 and row 2 in my first elimination. So in my second elimination, I must use row 3. I have to do something with row 3. Now remember, we're trying to eliminate the z's. I want to eliminate the z's. And because I have a negative 3z and a positive 4z, I have a negative and a positive, I think I'm going to use row 2 and row 3. All right. Now, I need those z's to become opposites. So I'm going to have to multiply this row by 4, because that would give me a negative 12z, and this row by 3. Okay. So what we're doing here is we're taking 4 times row 2 and adding it to 3 times row 3. All right, that's what we're doing. So let me come up here and let's write our new equations. So 4 times x would be 4x. 4 times 5y would be 20y. 4 times negative 3z would be negative 12z. And 4 times negative 37, that would be negative 148. Now multiply row 3 by 3. 3 times negative 2x would be negative 6x. 3 times y would be 3y. 3 times 4z would be 12z. and 3 times 27 would be 81. Now that you've multiplied row 2 by 4 and row 3 by 3, now you can combine them. So I'll combine 4x and negative 6x to get negative 2x. Then I'll combine 20y with 3y to get 23y. The z's will eliminate, and then I'm going to combine negative 148 with plus 81, negative 67. All right, so those are the two equations I'm going to use to create my 2 by 2 system. So 5x plus 3y equals negative 14, and negative 2x plus 23y equals negative 67. Now, I'm going to decide which variable to eliminate. Because I have a positive 5x in row 1 and a negative 2x in row 2, I'm going to try to turn them both into tens. So let's multiply the top by 2 and the bottom by 5 and see what we get. Okay, 2 times 5x gives us 10x. 2 times 3y gives me 6y. And 2 times negative 14 gives me negative 28. On the bottom row, I get negative 10x. Let's see, what is 23 times 5? That would give me 115y. And then 5 times 67, negative 335. Now add these together. The x's eliminate. So let's see, 121y equals 28 plus 335. That gives me 363. And divide. 363 divided by 121. So y is equal to 3. All right, now I'm going to plug that in. 5x plus 3 something equals negative 14. And substitute in the y, which was 3. So 5x plus 9 equals negative 14. Okay. Negative 14 minus 9. Okay, did something wrong. Oh gosh, this was negative 3. So this was, glad I caught that before I kept going. So this should have been 5x minus 9 equals negative 14. Now take negative 14 and add the 9. So 5x equals negative 5, and then divide to get negative 1. All right, now, last step, write down, I'm just going to write down my first equation from the original problem. And I'm going to put a negative 1 for the x, negative 3 for the y, plus 3z equals 23, and we'll solve for z. So this would be negative 4, negative 4 plus 6 plus 3z equals 23. So 2 plus 3z equals 23. Subtract the 2 and then divide. So z equals 7. So negative 1, 3, 7. And that concludes today's lesson, solving systems of 3 equations by elimination.